Hello everyone, let's go ahead and start another practice problem. So let's go ahead and read through this. It says that you've been hired as the data analyst for Cafe Nova, a coffee chain that's rolling out two new types of drive-through lanes, a fast lane for mobile users and a standard lane for on-site orders. The company's leadership wants to know whether the fast lane actually results in faster service times than the standard lane as they're considering expanding it nationwide. To investigate, you collect data on time in seconds it takes to serve a customer in each lane across 40 fast lane orders and 40 standard lane orders. The company believes the fast lane should be faster and wants proof to support this claim. You plan to test whether the average service time is lower for the fast lane than for the standard lane using a 5% level of significance. Okay, so let's go ahead and take a look at what we've got. So we entered the data into Excel and we got this output. So we see that, hey, we've got our groups of like our fast lane, our standard lanes. It looks like we've got some sort of two sample hypothesis testing. So we can go to our sheet that says two sample hypothesis testing and we can kind of look at a few things. So the first thing that we want to understand is, are we dealing with numerical or categorical data? It's like, what are we measuring? Now, there's a couple things here that can key us off. So one, we could just look at the output and notice how in every single one of these outputs, it's talking about a mean. So it looks like they were looking at a difference in true means for the muse. So that's kind of like one way. Another way, what are we measuring? We're measuring time, and time is a classic numerical piece of data. Let's go look at our questions. Like if we look at how the null and alternative hypotheses are written here, notice how they all are using the symbol mu. So there's a bunch of different ways we can kind of triangulate about what type of data that we're dealing with. So we've got two populations that we are dealing with, right? We're dealing with the true average time that it takes to get through the fast lane and true average time that it takes to get through the standard lane. And we are looking at the true mean time, and we want to look to see if the fast lane is faster. Okay, so we're at here kind of like stating our hypothesis. And we know that we're dealing with means. There's kind of two ways we can visualize this. I'm going to look at this left-hand side. So we're going to say that mu1 minus mu2, mu1 minus mu2. And we want to say less than 0 because I want to say that the fast lane has a shorter time. So a small number minus a larger number is going to give me a negative number. So I think this is going to be less than. So if I think that this is going to be less than, then the null hypothesis, as it says right below here, that the null hypothesis is always opposite of the symbol in the alternative hypothesis. So if I have a less than symbol here, I want a greater than or equal to here. Now, one question that we probably need to answer though is, like, notice here, I see that I've got a less than symbol here and I've got a less than symbol here, but notice I've got them in two formats. This is a mu sub d, that's a matched pairs format, and this is just a two sample hypothesis testing format. So we need to determine which one are we dealing with. So if we're looking at matched pairs, right, or we first decide that we're dealing with two sample testing, means or proportions, and we want to say double check that it's matched pairs. Because matched pairs is kind of interesting. It kind of floats between one sample hypothesis testing and two sample hypothesis testing because yes, we have two measurements, but we're really interested in the difference based on like an individual person or something that is linking those two measurements together. And so if we go to our one sample hypothesis testing, like, are we looking at a one-to-one linked difference in pairs? So we need to see if there's anything that is linking like the fast lane order with the standard lane. Like, is it the same person who goes through each of those? Is it the same order type that goes through a bunch of them? Are we doing it by the time of day that it is linking up each of these? And in here, there's nothing that's doing a one-to-one link. So we know that we are then doing two sample hypothesis testing that is not matched pairs. We're just going to highlight that one. Okay, next, let's kind of focus back in on, it says, okay, which analysis would we do? Okay, so if we go back to step five comes as a nice flow chart saying matched pairs. We said nope. And then we need to say, are the variances equal? And we need to do a Levene's test, or we need to look at that F test for variances. So if we come up to our output, we see that, hey, we've got an F test for our variances. It gives us an F test and a p-value. And remember, we compare this p-value to our alpha. And our alpha level that we are testing with up here, if we come down, is at the 5% level of significance. So if we're doing a 5% level of significance, we would say that, hey, our alpha value is less than the p-value, or that the p-value is greater than the alpha. So we would fail to reject. Come over here and look at Levine's hypothesis. So the null hypothesis is that the two samples have equal variance. The alternative is that the two samples have unequal variance. And what we did is we failed to reject because our p-value of 0.1, scroll up here, this p-value of 0.1 is greater than our alpha of 0.05. So because we failed to reject, we're going to use the equal variance. So coming down here, what do? First we do the f-test, and then we do the two sample assuming equal variances. Great, next one. What is your decision at the 5% level of significance? Okay, so we got to come back up here. We can now say that, hey, we're not looking at paired, we're not looking at unequal variances, we're just looking at it right here. And if we look at our p-value for a one-tailed test, because we decided that we were just doing a less than symbol in our alternative hypothesis, because of that, we are going to be rejecting the claim that let's look up here, we're rejecting the claim that these two could be equal to one another, and we are saying that fast is less than the standard. So we are going to reject the null hypothesis, and there is enough evidence to suggest that the fast lane is in fact faster. Okay, perfect. Let's go to question 4. How should the p-value be interpreted? Okay, this is a great question. Let's go look at how we interpret p-values. So if you've forgotten, there's a nice little handy-dandy part in step 8 where it says, what is the p-value? And it says it's the probability of observing the sample statistical difference or more extreme if the null hypothesis is true. So we can say, hey, is it the probability that the null hypothesis is true? That's not true. So the probability of making a type 2 error? Nope. Is it the probability that the alternative hypothesis is true? No. It is the probability that attaining a result as extreme or more extreme than the sample, assuming that the null hypothesis is in fact true. That's what our p-value is. Okay, question 5. What is a type 1 error in this context? So let's go to step 4, kind of in our flow chart, and we see a type 1 error is when we reject the null hypothesis, when we say that there really is a difference, that the fast lane is in fact faster, when in fact it isn't faster. So here, we would say, we would conclude that the fast lane is faster, concluding that the fast lane is faster. Okay, so it looks like it's just A or C, when actually it is not, or when actually it is. We want to say when it is not, because this is an error. There's a contradiction here, where we conclude that the fast lane is faster, when actually it is not. So on the flip side, in question 6, what is a type 2 error? So type 2 error is when we basically conclude that the two groups are the same, when in fact that they are different. So we would conclude that the fast lane is not faster when actually it is. That is a type 1. If we look at this one, concluding that the fast lane is not faster when actually it is not, that's a good choice. And that these ones are concluding when it is faster. These are going back to like looking at a type 1 error. Okay, next one. What is the correct test statistic? So don't forget that when we are looking at our outputs, we want to be able to look at our test statistic too. Remember, this is the number of standard errors away from the null hypothesis our sample evidence was, and it is negative 5.98. And there we go, negative 5.98. So whenever you're doing these, kind of like the big thing is, can we establish our null in our alternative hypothesis? Are there key words that we can key off of? So for us, some of these key words that we wanted to say is that, let's see, the company believes that the fast lane should be faster, right? That the fast lane should be faster. That's a key word right there. You plan to test whether the average service time is lower for the fast lane. So those are some key phrases there to help you out on setting up that alternative hypothesis. And then determining our testing method is really important to make sure that we are pulling out our information from the correct set of output, because a lot of this output is nonsense, right? We didn't need the paired, we needed the F to determine are we using our equal or unequal variances, and then we can grab all of the information that we need directly from our output. So anyways, that is a good preparation on how to do a 2-sample hypothesis test for means.